Hello children, this is the second video on coordination compounds. In this, we will see the classification of ligands on the basis of charges. On the basis of charges, ligands can be classified under three categories: neutral ligand, anionic ligand, and cationic ligand. Neutral ligand, as the name suggests, does not carry any charge, but they have an atom with the lone pairs which can coordinate it to the central metal atom or ion. For example, water, aqua, amine, carbonyl, nitrosyl, pyridine. So in case of water, oxygen has two lone pair of electrons which can donate it to the central metal atom. It can donate its one lone pair of electrons to the central metal atom or ion. NH3, nitrogen is the donor atom over here. Likewise, we have anionic ligands. Anionic ligands are those ligands which has a negative charge over it. Fluoride ion, chloride ion, cyanide ion. The third category is of cationic ligands. These are those ligands which carry positive charge and occurs very rarely in complexes. Example, nitrosonium ion, hydrazinium ion. Now, if you take the example of hydrazinium ion, one of the nitrogen has coordinated its electrons to the H plus ion, and there is still one nitrogen atom left with the lone pair of electrons which could be coordinated to the central metal ion. The second classification is based on the number of donor atoms. Now, on the basis of the number of donor atoms, ligands can be unidentate ligands, didentate ligands, tridentate ligands, tetradentate ligand, pentadentate ligand, and hexadentate ligands. Now, what is a unidentate ligand? They are those ligands which possess one donor atom and can form only one coordinate bond with a central metal atom or ion. Such ligands can attach them to the central metal through one point only. For example, H2O, it coordinates through oxygen. NH3, it coordinates through nitrogen. Carbonyl, it coordinates through carbon. Nitrosyl, it coordinates through nitrogen. Fluoride, or we say fluorido, it coordinates through F. Hydroxo, it coordinates through O. So there is one point only through which it can donate its lone pair of electrons to the central metal ion. Now, the next one is a didentate ligand. A didentate ligand has two donor atoms and can form two coordinate bonds. For example, in case of oxalato, which is written as C double bond O with a negative charge and C double bond O with a negative charge, you can understand with the example of an oxalic acid. You just remove off two hydrogen, it carries 2 unit negative charge. So there are two oxygen atoms which can donate to the central metal ions. So the donor atoms are two. That is why we call it as a didentate ligand. The other example is ethylene diamine or ethane 1,2-diamine, as we write in the short form as EN. Now look carefully at this compound. In this you have two nitrogen with lone pair of electrons which can coordinate to the central metal ion. So how many donor atoms are there? There are two donor atoms and it can form simultaneously two coordinate bonds. Moving on to the tridentate ligands. Now, tridentate ligands are those ligands which have three donor atoms. That means they can form three coordinate bonds. Example, diethylene triamine. Now, when you look carefully to this molecule, diethylene triamine, there are three nitrogen atoms with their lone pair of electrons. So, there are three donor atoms, all of them nitrogen. So, diethylene triamine is an example of a tridentate ligand which can form three coordinate bonds. Then we have the tetradentate ligands. As the name suggests, it has 4 donor atoms. Example of a tetradentate ligand is triethylene tetraamine. Now, it could be written as triene. Triene is the short form for triethylene tetraamine. And it has 4 donor atoms, all nitrogen. Next one is pentadentate ligand. Now, as the name suggests, it has 4 donor atoms. One example of a pentadentate ligand is ethylene diamine triacetatoine. Now, when you look carefully, you can see 5 donor sites. 2 are the nitrogen with the lone pair of electrons, and 3 are the oxygen which is carrying negative charge over them. So, ethylene diamine triacetatoine is an example of a pentadentate ligand. Pentadentate means 5 donor sites. Next is the hexadentate ligand. Hexadentate ligand has 6 donor atoms or 6 donor sites. Example, ethylene diamine tetraacetate, which is also known as EDTA. So here I have made ethylene diamine tetraacetatoine. Now when you look carefully, you can see 6 donor sites. 4 oxygen atom carrying negative charge and 2 nitrogen with a lone pair of electrons. So it is an example of hexadentate ligand. Now we'll see what are chelating ligands. When a polydentate ligand attaches to the central metal ion through 2 or more donor atoms in such a way that it forms a 5 or 6 membered ring with the central metal ion, it's called the chelating ligands. And the ring formed is called chelate. Now when you look at the complex which is written or drawn, you see ethylene diamine, which is a didentate ligand, it coordinates with the nitrogen atom to the central metal ion and it forms a 5-membered ring including copper. So it forms a chelate or the ring. So chelating ligands make a more stable compound. Now we'll see what is an ambidentate ligand. Some monodentate ligands contain more than 1 donor atom and it can attach to the central metal atom through any one of its donor atom. For example, if you take NO2 minus, it can either attach to central metal atom with N or with O. So it could be either with N or with O, not simultaneously. It's not simultaneously that N and O together are coordinating. So NO2 minus ion can coordinate either with N or with O. So it coordinates with N, we call it as nitrito-N. If it coordinates with O, we call it as nitrito-O. So O denotes the donor atom. The second example is SCN minus. It can attach to the central metal atom through S as thiocyanate S, distinguishing the atom through which it is attached. That's why we write down S. Or it can coordinate through N as thiocyanate N. So these are the examples of ambidentate ligand. This is another example of bridging ligands which we'll see while dealing with the nomenclatures.